Hi everyone. We're going to continue where we left off on the last part of our building our Backdoor web console. And in the last episode, we made it real time so that once you make some changes in one of the tabs or one of the browser windows, the other window is going to pick up those changes instantly. And today we have actually two more semi-hard problems to solve. One of them is capturing the output as it's being logged to the console. The other one is capturing the logs, and the logs are actually slightly harder. So we're gonna do capturing the output. And here's the difference. Let's start the thing. Here we go. We have our session, and now the two problems are related, but they're gonna be solved kind of independently. So the first one is that if we do something like IO puts hello, this is being printed out on the console here where the application was started. The other one is that the logger is actually doing the same. So again, those are two semi-related problems that will have kind of different solutions. And today we're going to focus on the first one, that if you do IO put string, it's not showing here. While doing some research on how to handle that, I stumbled upon several possible solutions and several possible examples of code where this is already solved. One of those is actually in the Phoenix framework itself. There's a Proxy for code reloader, which is doing more or less what we want it to be doing. So it's capturing output and also forwards it to the console, but also captures it for some reason internally. We will want to not to do the capturing internally, but we want to like multiplex the output so that it's being sent both to the console and it's being sent also to the web console, which is here. So it's going to be slightly similar. The other implementation of what we're doing is actually in the Elixir standard library. There's a string IO module which we are going to use, which also implements the same protocol that Erlang input-output system uses to output and input to read and write to standard input, standard output. So we can have a look at that protocol itself in this file as well. And if we the protocol is very simple and quite brilliant actually. Is asynchronous calls to something like where are those? Put characters, and then there are characters that are to be sent to the output, or there's version of the same call where you have we provide it with module function and arguments. I think that might be used for something like loggers or something like that then generate these characters. It also supports some encodings, I think, and there are several versions of that protocol. And the way in Erlang and Elixir this is performed is obviously there's a own process that handles input output, and it's every process in Elixir that is being started has associated such process. It's called gen leader. Oh, I'm having info. I think you can do it like that. Group leader, sorry, not gen leader. It's called group. It's called group leader, which is, you can see this is this PID, and if we send it those messages using the same protocol, so I'll just save it. This is right. Whoop, no. That's a keyword list. I think that should work, right? If we send it a message that complies with that protocol, for example, I think it's IO request. Let's have a look at this protocol again. It's IO request from I guess self reply us. What's the reply us? I don't remember. I had to look at it before. I reply us. I think it's like whatever. And then we have request, which is put cars, and then in the simplest form ABCD. Yeah, that you can see printed out that string ABCD to the console. So this is the default group leader that is handling input output, which is bound to this standard input and standard output Unix file descriptors, right? So our job is to basically implement something that will capture that protocol, and it will proxy it. So it will forward those messages to group leader that's been started by default for us, but also will proxy those requests and send it to our live view to be displayed. All right, and we are going to steal some code from, I think, from Phoenix, from this proxy, because it's a handy function that has all of the clauses we need here. So we're just gonna borrow it. Okay, all right. So where do we start? We actually will start at the supervisor. Here's our Backdoor session supervisor, and we'll start another child here, which is going to be something like that. Capture Backdoor session capture output, and I think we will provide it session ID and naming registration with this same via tuple mechanism we've been using so far. So it will start and register itself. Let's create that, and this is going to be our process that is implementing this proxy group leader. Session, is it lib session? Backdoor session .ex. Capture output. Okay. And as I said, we're going to steal some code from here, and actually also from code runner. So from the session code runner, we can take those two functions, I think, because they're going to be identical. So start link, that's the name registration, and then we have init session ID, except we don't need any bindings and anything else except the session ID on the state. All right, and this is stop. We don't really care about custom stop at the moment. Handle call stop. These are the two functions we need. So I'm going to copy that over. Here we go. So what this code is doing is this output is actually, in our case, state. So handle info state. We're receiving a message, and if it's IO request, which is put cars, then we capture it and we're doing something with it, like this, like this, like this. And if it's another different IO request, we're just sending it to the current group leader which is going to be this input output, standard input, standard output on the console. Okay. So this is okay. Here we're going to do our multiplexing. So in this case, we're sending a message to the group leader, cool, and Phoenix code is storing that on the state here. We don't care about doing that. And instead, we're going to send this message over the Phoenix pops up to the live view that it knows a new a new piece of code has been added. A new piece of output has been added, so new log has been added. Okay, so before we do that, we actually have to deal with Erlang characters and converting them to binaries. And if you have a look at this string IO, it is doing that exactly that under the hood. So I think we can just, again, we could just borrow the same code from here. But in that very case, we can just rely on that code being there and just use the string IO directly, so we don't have to copy that code. And instead reuse the code that is in the standard library. So we will start our buffer here in the init session. And this buffer is going to be string IO open. This is the input. It handles input output. We only care about the output though. So this is our string IO. This is the PID process ID of this linked process. That string IO open starts for us. And now here we can use it. So first of all, we can we have to flash out the what's there in this buffer at this moment. So string IO flash from our buffer buffer. All right, like that empties the buffer. And now what I'm going to exploit is that this thing, string IO, complies to the same input-output protocol as the group leader and as our proxy. So I can just forward the same message to it. So I will just send it to this buffer, this IO request in that very form. And what's that gonna do for us is to store that to convert it to Erlang Elixir binary and store it in the state, right? So that's done here. Now we need to fetch those contents. So I think you do that. You can like there's an input and output, and I can do it string IO contents of a buffer. That will give me what's in there, which is the converted message that was sent to our group leader. Okay, and now we can add it to our log, right? So backdoor session log, put log, and now we use the same via tuple to find this gen server, and session ID, I think it's here. So we're putting the log, which is going to be output, something like that. Okay, and our log doesn't need to be changed. However, I think in our code runner, this is where we're doing currently this logging. And we probably need to extract that to like own module, own function, or move it to the log. Well, basically move it somewhere so that we don't repeat ourselves. Do we have a place to put it? No, we got something like that. All right. Log helpers. All right. And I want to move this code there, I think. Okay. We need several things from it to make it work. So we need this via tuple to be available here as well, and we need this module functions to be imported to the code runner. Is the via tuple used? No, it's not anywhere. So I think that should do it. And we need to do the same from our capture output. So we will import it. And now, instead of doing that, we'll just do the log session ID. What's the API here? Log session ID value. Value, right. The value is a tuple with output. I think that's it. Let's clean it up a bit and let's restart it, whether it works. No, it doesn't. Undefined function log. Where in our capture output? Log. Ah, it's private. Okay, makes sense. Flash is undefined. Flash. One more time. Implementation. Specific. This means you forgot. Capture output at ex. All right. Yes, finally. All right, let's have a look at this backdoor thing now. So, okay. And it printed it out here. It doesn't seem to print it out here. Okay, yes, of course, because we're never substituting our group leader with our capture output, and we should do it. We can do it, for example, here before we execute that code. And there's a function to replace the group leader. We don't have to directly mandel into the process directory. There was a function somewhere. Okay, we can do something like that. And this is going to be a PID of our thing. And this is capture output. So that should find the PID and set it as a group leader, because this is already started. I think that's correct. Let's restart it one more time. Nope. Via tuple. Okay, because I removed it and now I need it back. Where's this via tuple? Okay. Self doesn't exist. It's being expanded to self. Self. Okay, yes, that's correct. That's better. All right. So one more time. And now we print it out of the console, but this crashed. String IO flash, no function. I was sure it's string. Okay, what's wrong here? String IO flash. That looks correct. Flash PID. So okay PID. That maybe that's not correct. Yeah, okay, yeah. It's okay and buffer. Okay, here we go. Start a new session and IO. There's a crash. Yeah, there's a crash. No function clause in backdoor format, and it wants to format output hello. Yes, that's correct, because we actually don't have such clause here. So we have input and output is going to be identical. Like that, I think. Let's have a look. Nice. And that's being printed here. Is it being printed here? Yes. Now we have one more issue. Error message IO reply. Okay, module session code runner. So our code runner is receiving IO reply. What's this error from? IO reply reference. Okay. I think we have to handle somewhere this IO reply, because it's like a protocol that acknowledges that is being sent and received right. So we're getting somewhere this unexpected message. It's not very helpful. It doesn't say where. It's probably here in the code runner. Init, and let's do that. And this is probably here. So we're replacing the gen leader here, but it's still like shouldn't. Well, there's probably gonna be infinite loop if we do that, but we can just try it. Is it here that we're receiving that message? I think it is. Yes, we got, and as expected, we got this loopy message, and I'm just going to handle it. So it's IO reply, and we don't really care about it. And state, we do no reply state. Cool. And I think we should also have like a default clause here that's like a message. Something like that. All right. Cool. I think that's fine. I must require logger. Here we go. So one more test. New session. IO. I think that's a compilation issue. It's gone after it's. Yeah, so it outputs. Let's spawn another terminal, make sure we haven't broken anything in that regard. All right, looking good. So thanks for listening and watching, and see you next time.